In this video, we are going to learn about addition of vectors when they are not in the same line. So here, the understanding in this video will help you find the resultant forces when the forces are not in the same straight line, because forces also are vectors. Similarly, you can add velocities, acceleration, any of the quantities which are vectors. Finding the addition or finding the resultants when they are not in the same straight line can be done if you understand the theory, the concepts in this video. So let us start this lesson. We know that the resultant force is equal to the sum of two forces if the forces are in the same direction. If you look at picture number 1. Picture 1 relates with the point number 1 here. Two forces in the same direction. You have two forces, 60 newtons and 30 newtons in the same direction. How do you find the resultant? You simply add them, 60 plus 30, 90 newtons to the right? Similarly, the resultant force is equal to the difference between the force if the force are in opposite direction. So if you have this trolley, you are applying two separate forces but in opposite direction. Please understand the forces here are in the same line. They are parallel lines, but they are in the same straight lines. So when the forces are in opposite direction, you subtract them to find the resultant. So here if you see 30 minus 10, so 20 newtons. And what is the direction? Towards the right. Force is a vector quantity. Please do remember, whenever you're finding the resultant force, you have to give the magnitude, which is 90 newtons as in the first picture. You have to also mention its direction, which is towards the right. Similarly, the second picture, if you see, you are giving the magnitude and its direction. Fine. So this is easy to understand. Adding, subtracting vectors is easy when they are in the same straight line. Now consider this scenario. How do we add forces which are not in the same line? So you have a ship. The ship is pulled forward by the resultant of the forces from the tugs. So you have a ship maybe which is not functioning, its engine is down or something. Then you are using two tugboats to pull it ahead. If you see, the two tugboats, they are applying forces in the direction of the red solid arrows, right? These are the two forces applied by the two tugboats. But what is the resultant? What is the direction in which this ship ultimately moves? The ship ultimately moves in the direction like this. What is this? This is your resultant force. This is your resultant force. So how do you find the resultant of the forces when the forces are not in the same line as in the case here? This is also simple and easy to do. You use a fundamental. What is that fundamental called? We use the parallelogram rule. Let us understand the parallelogram rule with the help of an example. Practice question. You'll need a ruler and a protractor to do this question. We'll understand the parallelogram rule with the help of an example, right? So please bring your ruler, please bring your protractor. You can pause the video here for a moment, get these two stuff, get back on your seats, and then continue with the video. Fine? So what is the question? Find the resultant of two forces, 4 newtons and 5 newtons, acting at an angle of 45 degrees to each other. So you are given two forces. So let us draw a rough diagram how the scenario would look like. So there are two forces. One is 4 newtons. Other one is 5 newtons. Acting at an angle of 45 degrees between them. This is your question. So what is the resultant of the forces 4 and 5 in such a scenario when the forces are not in the same line but there is an angle of 45 degrees between them? So let us move step by step. So let us start with what you do as the first thing, which is your step 1. First thing that you do is choose a scale, because this is an easy scenario. 4 newtons, 5 newtons, we can choose a scale like 1 centimeter is equal to 1 newton. Or you can also take 2 centimeters is equal to 1 newton. Your wish, choose a scale. First thing, write in your notebooks the scale that you are taking. If you want to be adventurous, you can try a different scale. You can take 2 centimeters as 1 newton. If you are taking 1 centimeter as 1 newton, then 4 newtons is 4 centimeters, 5 newtons is 5 centimeters. If you are working with 2 centimeters as 1 newton, then 4 newtons is going to be 8 centimeters and 5 newtons is going to be 10 centimeters. What is this? 8 centimeter, 10 centimeters. We are going to draw some lines which are going to be 8 and 10. If you are choosing a scale of 2. If you are choosing a scale of 1, you are going to draw lines which are 4 and 5. So here I took 2 scales to explain how you can work with the scales of your wishes. So for my explanation here, I'll carry on with the scale which I have chosen here, which is 1 centimeter is equal to 1 newton. But you can carry on with any other scale that you want. You'll ultimately get the same answer. Alright, so what is the step number 2? Now you take out your ruler, you take out your protractor. Draw the 4 centimeters and 5 centimeter lines with an angle of 45 degrees between them. Draw neat lines. Draw neat lines. You can draw 5 centimeters line. Use your ruler. It should not be a rough sketch. I am doing a rough sketch here because I have limitations, but in your notebook you'll use your ruler and draw a perfect 5 centimeter line depending on your scale. If your scale is something else, your line will be something else. Right? Draw another line which should be at 45 degrees to this line, something like this. But this one has to be 4 centimeters long. It should be shorter, 4 centimeters. This much is basic geometry. You should be able to do it. Another line will be 4 centimeters. And the angle between them should be 45 degrees. If you are not done with this work yet, pause this video and then play the video again to understand the third step. Draw 2 lines, 5 centimeters and 4 centimeters with an angle of 45 degrees between them. Remember that we are working with vectors, so put an arrow head at the end of the line because vectors are denoted as arrows. Do not forget it, put an arrow at the end, or you can skip the arrow. You can place all the arrows after you have finished your working. Right? Let's come to step number 3. What do you do in step number 3? Complete the parallelogram. You have got 2 sides of the parallelogram. Consider these 2 lines that you have drawn as the 2 sides of the parallelogram. Now complete the parallelogram. Now you are going to do some rough work. So draw some dotted lines. Right? Draw a line at the top which is parallel to this line. These 2 lines should be parallel. Dotted lines because these are your rough lines. Similarly, another line. This one is parallel to the 4 centimeter line. This completes your parallelogram. Complete the parallelogram, all of you. Pause the video if you want, and you can play the video to come back and understand point number 4. So what is point number 4 now? Now that you have got the parallelogram, the diagonal is the resultant vector. Let us draw the diagonal. Now there are two types of diagonals possible. One diagonal would go like this, other one will go like this. We will consider the diagonal which goes in between the two lines, right? In between the two force vectors that you have drawn, you have to draw the diagonal from there in between space, right? So what is the resultant? Let me use a green color now. This is your resultant. This is your resultant vector. Resultant of this 4 newtons and 5 newtons. 4 centimeter represents 4 newtons. This is your 4 newtons force. This is your 5 newtons of the force. And what is the resultant force? This is your resultant force. This is a force, so it should have an arrow at the end. Please do not forget the arrow at the end. That's your resultant force, right? So that's how you find the resultant force. The next thing that you do is measure its length. Use your ruler, place it on the resultant force and find its length. Find its length. If you are working with a scale of 1 centimeter, you'll see that the length comes out to be somewhere around 8.3, 8.4 or 8.2, near about this number. And use the scale to find its magnitude. Use the scale. So what is the magnitude of the resultant force? Because the scale is 1 centimeter is equal to 1 newtons. So what is the magnitude of the resultant force? 8.4 newtons. Alright, now the last point is, one more thing is left. Are you done? There is one more thing left to be done. You have found the resultant force, but there is something which you have still not figured out, which completes your answer. What is that? Take a pause, think about it, and see if your answer tallies with what point I am going to show you on the screen now. Don't forget to measure the angle of the resultant with one of the vectors to give its direction also. So you have to give the direction as well. You have to give the direction. Either you measure this angle, say this is alpha. You can say that your resultant is 8.4 newtons at alpha degrees from 5 newtons. You can say either you answer this way, or you can measure this angle, say theta, or you can say the resultant is 8.4 newtons at theta degrees from 4 newtons, whichever way you want to give the answer. So your answer should be something like this: 8.4 newtons at 21 degrees. When I measured the angle here, I got it to be 21 degrees. So either you can say 8.4 newtons at 21 degrees from 5 newtons, or another way of writing the answer would be 8.4 newtons at 24 degrees theta. This other angle would be 24 degrees from 4 newtons. You have to give one of them as your answer. Either this or this, not both. Both are not required. One of them you can give as the answer. Alright, so you have found the magnitude, you have found the resultant vector, resultant force, and you have found its direction. That completes your answer. A vector quantity has a magnitude and a direction. Force will have a magnitude and a direction. You have given both the magnitude, which is 8.4, and its direction 21 degrees. From where? From 5 newtons. Alright, so that's your parallelogram rule. Practice more and more questions on parallelogram rule. It's fun and interesting to do, right? It's a 5-step process, simple and easy. Some examples of the scenario from our day-to-day lives where two or more forces act on an object and you see a resultant force. Say for example, two people picking of water, what is the resultant force? And somewhat this direction. Ultimately the bucket will move upward. Though the two forces are in separate direction, ultimately the motion of the bucket is upward. Why? Because the resultant force is upward. Similarly, the other picture that you see, this is an example that we have already understood. The ship which is broken is pulled by two tugboats. The tugboats are moving in some other directions, but the ultimate motion, the resultant motion, is in the forward direction. Alright, so this was all about understanding the parallelogram rule of finding the resultant vector. This rule can be applied to forces or any other vector quantities like velocity or acceleration or moments or momentum. Whenever you have to add vectors, parallelogram rule is one thing that you should always think about. So there are practice questions in the videos where we have taken up the exam style questions to understand this topic better. You can go through it. Thank you.